Hey guys, welcome to yet another session by Scaler, and in this particular session we're going to look into the features of OOPS. So basically OOPS in the sense object-oriented programming language. Okay, so we'll be looking into the features of it. So now before we move on with this session, please make sure to subscribe to Scaler's YouTube channel so that you don't miss our upcoming videos, and also leave a like if you enjoy our content. And if you have any queries, leave a comment down below and we would address them all. So now let's understand what will be covered. So to begin with, we'll be looking into what exactly is OOPS, and then look at the features around OOPS. So what are the features we'll be looking into? We'll be looking into inheritance, encapsulation, polymorphism, abstraction, classes, objects, constructors, deconstructors, and more. Okay, so these are the things we'll be looking into. Now without any delays, we'll get into the session. And also if you want to learn more about OOPS, we have an interview bit blocked linked in the description box below, and you can click on it and it'll take you to the blog and you can learn more about OOPS over there. So now let's start with the session. So guys, let's start with the session by understanding what is OOPS. That is object-oriented programming, right? Object-oriented programming is a programming model that uses classes and objects. So this is the most common explanation anybody gives. So let me make it even simpler so that you guys can understand even better. So it's utilized to break down a software program into reusable code blueprints called classes. So instead of writing a single program where the entire code is available in a single code file divided into multiple units. Instead of that, what if we make a code for a particular application or a particular software program into different parts which could be reused again and again, right? So you are creating multiple classes, right? So that's what you're doing, that you may use to build specific instances of things. So object-oriented programming languages, JavaScript, C++, Java, Python, these are some of the object-oriented languages. So individual objects are created using class templates as a blueprint. For example, MyCar and Golden Retriever are two particular instances of the abstract class. The attributes specified in the class may have unique values for each object. Okay, so basically a class could be a car, right? And under a car, the object could be, again, my car. There could be other specific instances of it as well. So dog could be a class, and under dog there could be golden retriever. There could be other kinds of breeds like dachshund or boxer or whatever, right? So you could make them into objects. A class is a generic template that you may use to create more specialized concrete things. So class are more commonly used to indicate large groupings with similar characteristics. So classes may also have functions known as methods that are exclusively accessible to objects of that kind. These functions are specified inside the class and execute an action beneficial to that particular object type. So basically when you create a class, inside this classes, you can have any number of functions you want. So those functions could be beneficial to the object which you will be creating within that particular class, or the object which you will be creating in another class which is calling this particular class's function. So basically you are basically connecting two different classes by creating an object of the previous class into the new class, and by using this function for that code. So basically it is a combination of multiple classes put together, and for each and every class you could create objects can be different. Again, it doesn't have to be the same. Objects could do different things as well, but you're just creating an instance of the class which you have created, and that particular instance could be used in any way possible. So now top features of OOPS. So by first, let me just give you some of the top features, and let's then go ahead and start discussing them. So mainly the top of the mind, what are the things you will come up with is polymorphism, inheritance, encapsulation, abstraction. And after that, obviously classes and objects. So the top two, message passing, reusability, are some of the features as well. But the main features are polymorphism, inheritance, encapsulation, and abstraction. Okay, so now let's look at all of these features one by one. Starting off with inheritance. So in layman's terms, the attributes that you inherit from your parents are a simple illustration of inheritance. For example, you would have like got some attributes from your father, you would have got some attributes from your mother. So you're basically inheriting those attributes from them, right? It could be a physical attribute or a mental attribute, or like anything, like it could be a habitual attribute. So
Yeah, so but you're inheriting it from your parents. So your parent are basically the superclass, and from them you are inheriting, and you are the subclass. You are basically a subclass of them. And when you have offsprings and they become your subclass, so this is just an example. Obviously, they don't become a subclass, but when you consider it in an consider that example with inheritance, you're taking that analogy. So in that case, you would be the superclass whose basically that particular offspring, that subclass, will be inheriting the attributes from you, right? So this is a simple example of inheritance. So it doesn't have to be that everything, the complete entire attributes will be inherited. Doesn't have to be, just a part of it can be inherited. For example, classes may inherit characteristics from other classes thanks to inheritance. So using inheritance, other classes could inherit attributes from other classes instead of typing every single attribute it requires. Parent classes, in other words, extend properties and behaviors to child classes. Reusability is aided via inheritance. For example, let's say you're creating a class. That class could be used to provide attributes to 10 different classes, right? It doesn't have to be just one superclass can have only one subclass. Not that case. There could be 10 different subclasses getting attributes from the same superclass. So by doing this, you are reusing code. By reusing code, you are making your code even more efficient. That's exactly what inheritance gives to you. And prototyping is another name for inheritance in JavaScript, especially. So a prototype object serves as a base from which another object may derive its features and actions from. So basically, again, it's the same concept. Another object is using another prototype object and getting its attributes and using it for itself. Thus, you may use multiple prototype object templates to form a prototype chain. Inheritance is passed down from one generation to the next parent. So again, so this is the same concept again and again, they're just repeating it. To be very, very simple, inheritance is when the subclass gives away its attributes to a subclass, or the subclass gets some attributes from the superclass. Talking about inheritance in code terms, a subclass is basically inheriting attributes from the superclass so that it could reuse the code which is already available in the superclass instead of writing that code again within the subclass, right? So this is exactly inheritance. Moving on. Now let's look at encapsulation. So encapsulation is the process of enclosing all critical information inside an object and only revealing a subset to the outside world. For example, code inside the class template defines attributes and behaviors. To be very simple, let's take an application. Let's take a very common application. Let's take Uber. Okay, so Uber, when you open the application, what do you see? You see a map. You can choose your location. You can choose your drop location, and then you can basically choose what type of a cab do you need, and you select that, and then you book the cab. So what do you see? You only see the things you can do over the application, but do you see how exactly is that function performed? Do you see how where exactly is that code stored? Do you know how exactly that logic works? You do not, because it's encapsulated, right? So this is a very simple example. That's what I'm trying to say. So basically they encapsulate all of these in order to just give you only what is required to show to you. Only the information which is required for you to see will be shown. The all the other critical information would be inside an object, and nothing will be revealed out of it. Only a subset of it will be revealed. The data and methods are then enclosed in the object when it is created from the class. So inside a class, encapsulation conceals the underlying software code implementation and the internal data of the objects. So to be again the same thing as I told you with the Uber application, you would only see the a topmost implementation of it. You wouldn't see the code. You wouldn't see how exactly it works. You wouldn't see the data which it requires in order to make those things you see on the screen, right? You can't see that. So encapsulation necessitates designating certain fields as private while others are made public. So to be very simple, the parts which are made public is what you see in the app. The parts which are made private will not be shown to anybody, because that's what exactly encapsulation does. It tries to conceal the critical code and data within the app itself, and it won't show it to you. So methods and attributes only available from other methods in the same class make up for private or internal interface. Methods and attributes that are available from outside the class are known as public and external interface. So within the class, it's private because other classes can either inherit it, or it could be used, the code could be used, but when it's public or it's outside of a particular class, then it will be shown to you. So that's exactly how this works. Only those things will be shown to you as a end user, right? And so this is a very simple illustration of encapsulation, and using a capsule is the most common method of showing this. So methods and variable, the entire thing is a class. The class is basically the capsule, and the methods and variables are encapsulated within it, right? And only whatever has to be shown to you will be shown to you. Also, encapsulation demonstration in real time. Let's take an example of a real world example instead of an application, but this is a real world example. So one of the most practical examples of encapsulation is a school bag. Our pencils, books, and other items may be kept in a school bag. The following are some of the advantages of encapsulation: data hiding. In the case the user will be unaware of the class's internal implementation. Even the user will have no idea how the class stores data in variables. He or she will be aware that the values are sent to the setter method and the variables are initialized with that value. To be very simple, for example, when you are registering with Uber, you are giving all your information. So you do not know how that data is being stored, but you know that data is being stored because you are able to see that in your profile. So that's data hiding. Next one is increased flexibility. That is, depending on our needs, we may make the variables of the class read only or write only. If you want to make variables read only, remove the setter methods like set name, set age, and so on from the above program. If you want to make the variables write only, remove the get methods like get name, get age, and so on from there. So basically what they are saying is, if you want to make it read only, you'll have to remove certain methods. If you want to make it write only, you'll have to remove the get methods. So this you can do in the code itself. So this is not an external implementation, this is the code implementation. All right, and finally it also promotes reusability and makes it simple to alter to new needs. Mm, so as the data is hidden, as the logic is hidden, you can use the same logic multiple times. That's exactly what they're coming to say. Yeah, coming to the next one, which is abstraction. So abstraction refers to the user's interaction with just a subset of an object's characteristics and operations. To access a complicated item, abstraction uses simpler high-level techniques. Simple items are used to show complexity, keep complicated information hidden from the user. So very simple things can be shown as complex things in the code, right? You don't have to basically make it complex enough. You can just use the simple code which could be shown as complex to the user, but the actual complicated information will be hidden from the user so that they don't see it. So simple classes are used to indicate complexity in abstraction. Encapsulation is an extension of abstraction. It's an extension, right? So a real life example of abstraction. Abstraction reveals just the most significant facts to the user while hiding the underlying intricacies. For example, when we ride a bike, we only know how to ride it, but not how it works. We also know how a bike works on the inside. We also have no idea how a bike works inside. But again, it doesn't work for everybody. Somebody could know, the person who made that bike or a mechanic would know how it works, but don't think about an actual real world example. Think of it as an application. For example, again, let's say you're using Instagram, you're posting a photo. You know how to post a photo. You know it shows up in your profile once you post it, but you do not know where the photo is stored or where it goes on what server it gets stored or how exactly that image is processed, right? So that's exactly what they're coming to say. So you know that it happens, but it is covered with a layer which you will not be able to see. That's exactly what abstraction is. As said again, it is similar to encapsulation, but it's just an extension of encapsulation. Yeah, sorry, it's encapsulation is just an extension of abstraction. So what are the advantages of abstraction? It simplifies the process of seeing things in their entirety. Code duplication is avoided and reusability is increased. Because just the most necessary information is showed to the user, it helps to enhance the security of an application or software. Because if you show a lot of information outside, unauthorized or malicious users would be able to get that information and use it for uh, obviously certain purposes, to hack the application or get into the uh, application's database to steal information. So that could be avoided using abstraction. And this is the third one. Coming to the next one, which is polymorphism. So polymorphism refers to the creation of items that have similar behavior. So for example, if you look at the right side, shapes is the main title, and then there are other forms. So polymorphism, it's again a very common term. Poly basically means many, morph basically means forms. So it's many forms, and shapes is a form, and under shapes there are many forms. So basically, the in one class there could be many forms. So under shapes there is circle, square, triangle, rhombus, and there are so many other shapes. So this is just an example, right? For example, objects may override common parent behaviors with particular child behaviors through inheritance. Method overriding and method overloading are two ways that polymorphism enables the same method to perform various actions. So examine how polymorphism in the actual world are interconnected with examples. So let's look into that. Take, for example, let's say your mobile phone. It has the capability of storing your contacts. Consider the following scenario. So you wish to store two numbers for one individual, right? So the same person has two different numbers. So you may do this by storing the second number under the same name as the first. So again, how does this work? You're storing two numbers under the same person, and yeah, you are able to do it because it's two different values for one single parent, and you are able to do that. This is one scenario, okay? And the second scenario is you wish to store two numbers for the same individual in an object-oriented language such as Java. Create a function that will accept as arguments two integers and the name of the individual to some function void create contact that will be defined later. For example, what they are coming to say is when you want to do this using a code, in this case, you will be creating a function. That function should be able to accept two different integers, that is int number one, int number two, and string name is the name of the contact you want to create, and the function name you are creating is create contact. So you are providing three different variables, right? String, name, and int number one and int number two, three different variables, and the method name is create contact, and you are able to do the exact thing you want to do in your contacts application in your code. So this is how again it basically works. If your app phone mobile phones operating system is using Java, so this is how it would work. They would use either overloading or overriding according to the scenario it demands. So now talking about overloading and overriding, let's look into them. First of all, overriding. So overriding is basically a runtime polymorphism. Okay, when a child class overrides a parent's class, the child class might offer an alternative implementation. So consider a family of three consisting of the father, mother, and son. The father makes the decision to teach his kid to shoot. As a result, he brings to the range with his favorite rifle and teaches him how to aim and fires at target. The father, on the other hand, is right-handed when the kid is left-handed, so they each have their own way of handling the pistol. But because of their differing orientations, the father was concerned that he may not be able to teach his son how to shoot. The son, on the other hand, was astute and chose to flip his father's hands, putting his dominant hand on the trigger rather than the father's, specifically the right hand. By significantly changing the learning process, the son was able to grasp the skill of shooting. So, to be very simple, uh, so the child doesn't have to possess all the attributes as a parent class. There could be some similarities, but it doesn't have to possess all the attributes. But in this case, it's dynamic or late binding, right? So dynamic in the sense it could adjust automatically according to the need. That's basically method overriding, but there is more to method overriding. So to be very simple, so it's basically two different methods with the same name, but they are in different classes. For example, the parent will have a method. Let's say the method is add. You're trying to add two numbers, but the method has no. Let's say it has no variables. Okay, it's just int add. That's the method which is in the parent class. In the child class, there is another method. Again, it's just int add and brackets. Okay, it's another method. So now these two methods are there, but the thing is, you'll have to make sure that uh, if the parent classes method is invoked, the parent classes method will work. This child classes method is invoked, the child class method will work because they are in two different classes, and even though they are overriding, that is using the same method name and the same parameters. So as they are in different classes, when the parent is invoked, the parent method will work. When the child is invoked, the child method will work. That's exactly what method overriding is, and this only happens in runtime. So when the code is running, that's when the code figures out on which method to invoke. Coming to the next one, which is method overloading. So in this case, it's compile time polymorphism. So this happens while the code is getting compiled. So all the two methods or functions may have the same name. The number of arguments given into the method call may vary. So in this case, basically the parameters will be different, but the function name or the method name would be the same. Again, let's say you want to add numbers. So in this case, let's say there's add the function name. So int a and int b, you are trying to add two numbers. Again, there is another function add within the same class, but in this case you're adding three numbers, int a, int b, and int c. Okay, and there is a third method, but in this case it's not integer, it's double. That is, this particular function is float. So it's basically double add, and the way parameters could be anything you want, because the other two methods were integers and this is a double. So basically what exactly I'm trying to say here is you can have the same method name, but the parameters could differ, and or you could have the same method name, but the methods uh, data type also could differ, and that would basically differentiate between the methods within the same class. So how it will differentiate? It will differentiate according to the parameters you will be providing. So with the help of a simple example, it may be comprehended in simple words. A class addition contains two add methods, one with arguments int a and int b, and the other with three integers int a, b, and c. As a result, the add function is considered overloaded because it has the same method name, but it has different types of parameters. The number one has int a and int b. Number two has int a, b, and c. So in the first one, when you're trying to invoke the first method, you only provide two values. When you're trying to invoke the second one, you provide three values. So that's what they have provided here. If you provide add 20 and 30, the two parameter function will get invoked. If you provide add 10, 20, 30, or any other three numbers, three parameter function would invoke. So this is basically method overloading, and this is compile time polymorphism. Moving on. So now let's look at objects and classes one more time. We already saw about them, but again, we'll just brush up on them and then go ahead with any other topics which are remaining and finish with the session. So an object is a self-contained segment with the attributes and processes needed to make data usable in programming terms. From an object-oriented perspective, objects are the main building pieces of programs. In each application you create, you may employ a variety of objects of various sorts. So each kind of object is derived from a specific class of the type. Consider an object to be a sculpt of the real world perceptions, processes, or objects that are important to the application you're designing. So in basic terms, objects are the fundamental data types in object-oriented programming languages and are used to build object-oriented programming. And again, to be very, very simple, when you create a class, if you want to reuse the code from that class, you need to use an object. So when you create an object, it basically instantiates that particular class. So whenever you're using the object, it basically uh, reuses the code which is in that particular class, right? So that's exactly what object is. And then classes, it's a construct, is used to describe an individual type. A class is instantiated into instances of itself, referred to as class instances or simply object. As I told you, the object is used to instantiate the class itself. A class defines ingredient members that allow its instances to have position and behavior. Member variables or instance variables facilitate a class instance to maintain its position. On the other hand, other kinds of members, easily methods, allow the behavior of class instances. Again, this is the same jargon repeating. So basically, you can have a class. Within that class, you can have any number of methods. It could use method overloading, method overriding. So that involves the other concepts which we already learned: encapsulation, inheritance, abstraction, polymorphism, right? So in this case, let's take an example. A bird class would symbolize the properties and functionalities of birds. A single particular bird would be an instance of the bird class. Basically means there could be a bird class, and a sparrow would be an instance of the bird class. A parrot would be an instance of the bird class. But the bird, that is because all of these birds will have common attributes, and those common attributes make this particular class, but all of these individual birds are basically the objects, and there is a set of access specifiers in classes as well. So private specifiers restrict the entrance to the class itself. So this is where encapsulation comes in. You're using the private classes to encapsulate or close down the visibility for your users. They won't be able to see whatever is inside the private classes. They will only be able to see what's inside the public classes. Protected specifies enables the class itself and all classes under it to access the member, and public means that member can be accessed by its name using any code. Okay, so protected only the class itself can enable it, but public anybody could see it, but private it's completely closed. So these are classes. Okay, finally, the last topic we are going to look into is constructors and destructors. If you just look at the image, it would explain it very, very simply. So constructor, you are constructing one particular object. Destructor, you are destroying that object. So now let's look into it even a little in deep. Constructors in most object-oriented languages have the same name as a class and a public. So let's say I'm creating a class A. So the constructor itself would have the name A. Okay, so that's exactly how a constructor is created. Whenever you create an object, it is automatically called. A constructor may be overloaded, which means that multiple argument lists can be used with the same name. The function object in PHP 5.0 is your function underscore construct. Normally the attribute values would be initialized in a function object native code. Okay, so it's basically the same thing. You can use underscore construct in order to bring in a constructor manually. If you don't bring in manually, when you create a class and create an object within the class, it automatically creates a constructor. The destruct method is optional. Using the destruct method, you can delete or destruct that constructor which got created, because when you shut down the files or close down database connections, or when you stop running the code, it automatically destroys the constructor. So you don't have to destroy it. It automatically cleans up the object. But if you want your code to be clean, then it's better to use a destructor. So I think that's basically it for today's session, guys. So I hope all the features of OOPS are clear, and we've looked into many different concepts. I hope everything is clear. If something is not clear, please leave a comment down below and we would answer it and make that concept clear to you. So on that note, thank you so much. Meet you in another session.